Okay, hi boys and girls, welcome to my YouTube channel. Please don't forget to share, like and subscribe. Okay, so today we are going to tackle this concept, maximum power transfer theorem. This is one of the 6 theorems in your module. Okay, so it states that the maximum power in a circuit is delivered if the load resistance is equal to the total resistance from the what? From the linear network. This is the general thing. Okay, I'm going to explain what is the meaning of this statement. The maximum power in a circuit is delivered if the load resistance is equal to the total resistance from the what? From the active RLC circuit. Okay, see, this theorem is applicable to both DC and AC voltage source. If you have a direct current voltage source, if you have an AC voltage source, this is also what? Applicable. The theorem is not applicable for unilateral or nonlinear networks. You know what is a unilateral network, what is a bilateral network, what is a nonlinear network, what is a linear network, what is an active network, what is a passive network. You should know all these things. Okay, so what is the meaning of this? See, I have a simple circuit. This is a simple circuit with me. I want you to have a look on this what? Circuit, and then to write it. It's a simple circuit. This is the voltage source, okay? And this is the resistor in this circuit. And this is also the load resistance. So I have two resistors, okay? This is the load resistance. This is also another resistor in series with the load resistance. And we also have this voltage source which is in series with these two resistors, okay? See, the maximum power is delivered to this load resistance only if Rs is equal to Rm. Okay, maximum power is delivered to this what? To this load resistance only if this Rs, this supply resistance, is equal to the load resistance. Okay, so this is what maximum power transfer theorem is saying. Now I have a network, and this network now is an active RLC circuit. This is an active RLC circuit. Okay, in this case I'm saying it is an active circuit with the resistors only. I'm not going to put the inductors or any capacitor now. I only have many resistors which are making up this active circuit. Okay, and this is the load resistance. This is the load resistance. Suppose you want to calculate the maximum power delivered, the maximum power dissipated by the what? By this load resistance. Yeah, you want to calculate the maximum power from this what? From this load resistance. So how are we going to do this? See, I am going to reduce this network into Thevenin's equivalent circuit. Okay, I'm going to reduce this complicated circuit into Thevenin's equivalent circuit. And this is nothing but the thing. You are supposed to calculate the Thevenin's voltage. And you are also supposed to calculate the Thevenin's what? Resistance. Now you have the Thevenin's voltage and you have the Thevenin's resistance. You are supposed to write, you are supposed to draw the Thevenin's equivalent circuit. This is the Thevenin's equivalent circuit. I'm going to draw it here. Positive, negative. And what is this? This is VTH, Thevenin's voltage. And what is this? This is RTH. Okay, in order for you to calculate this VTH and RTH, you are supposed to remove this load resistance. Okay, that's why you see here there is no load resistance. Then with this circuit only, you determine VTH. With this circuit only, you determine this RTH. Okay, now this VTH I have, and now this RTH I have. Okay, in order for you to have the maximum power now, it means what? It means you are supposed to put this RTH here. I'm going to put the RTH here. See, if it is like this, I'm saying this is the Thevenin's equivalent what? Circuit. Okay. In order for us to get this, we removed this. Okay, and we have this and these ends. Now I can calculate VTH and RTH. Okay, this is lecture number 2. You can check the Thevenin's equivalent circuit. So this is the Thevenin's equivalent circuit. Now I have the Thevenin's equivalent circuit. Okay, right? And the load resistance I'm going to put. This is RL. So in order for you to have maximum power now, in order for you to have maximum power, okay, right? It means what? It means this RL should be equal to RTH. This RL should be equal to what? To RTH. Okay. So see, the question will be like this. They will give you the problem and they will say calculate the value of RL, which makes sure that the maximum power is delivered to the circuit. Okay. So in order for you to calculate the value of RL, you just calculate the Thevenin's resistance. Okay. So now if you find the Thevenin's resistance, you say in order for the maximum power to be delivered to the circuit now, it means RL is equal to what? Is equal to the value of RTH that you have calculated. Okay. Now let's say you want to calculate this maximum power. I'm going to calculate the maximum power across this load resistor. See, power is equal to voltage into current. Okay, this is the thing. Okay, but we know what? V is equal to IR. This is the thing that you what you know. You don't have current. So now I is equal to V divided by R. Substitute for I by V by this one. So V is equal to VTH divided by what? Divided by R. So this V to the power squared. P is equal to V squared divided by R. So what is the voltage across this? What is the voltage across this load resistor? We want to calculate the voltage across this load resistor. You know voltage division rule. Okay. So this RL is equal to what? Is equal to RL divided by what? Divided by RTH plus RL everything into VTH. Okay, so this is nothing but the voltage across this load resistance. The voltage across the load resistance is equal to this divided by this into VTH. But see, this RTH is equal to RL. This RTH is equal to RL in order for the maximum power to be delivered. So this is equal to RL divided by, here I'm going to substitute RTH by RL plus RL into VTH. Now I have RL divided by 2RL. Okay, now RL divided by 2RL. What is the answer now? This is R divided by 2R. Okay, this and this will go. Okay, it means the answer is half of VTH. So the voltage across this load resistance is half of VTH. Which means again the voltage across this RTH is half of VTH. Why? Because they are equal. And if you add the two voltages, you are supposed to get VTH. Now I'm going to substitute. This is equal to P max is equal to V. What is the value of the voltage across this load resistor? This thing. So this is VTH divided by 2. Okay, you can write this as VTH divided by 2. This is the same thing, right? Then to the power what? To the power 2 divided by R. So what is the answer? This is VTH divided by 4r squared divided by 4r this is the load resistance. This is the formula. So if you want to calculate the maximum power delivered now, you just say Thevenin's voltage to the power 2 divided by 4R. This is the load resistance, this is the Thevenin's voltage. So this is all about maximum power transfer theorem. Don't confuse yourself. In order for the maximum power to be delivered, this RTH should be equal to RL. So if you have VTH here, it means here the voltage is half of VTH and here the voltage is half of VTH. Now you want to calculate the power across this load resistance, the maximum power across this load resistance. The voltage across this is half of VTH squared divided by the resistance is nothing but the load resistance. Then only you get this formula. Okay, thank you boys and girls. You have a good day. I will see you in the next class.